So next we wanted to take a little look at Nevada, which is kind of the center of the Great Basin. And we have something called the Nevada Climate Tracker, which averages up all the 4-kilometer pixels in the state from PRISM and forms a kind of a statewide average. So this is something that we see quite commonly when we look at the state of Nevada. This is the long-term temperature of the state of Nevada for the water year. So this is current up through just a few weeks ago, October through September. All the water years in the record compared with last year. So what this shows, oops, I skipped ahead there. So what this shows is started on the cool side up until the 20s and early 30s. Then here's 1934, which is the warmest year in the Nevada record, and the maximums have stayed kind of haven't really changed very. Sorry, the mean temperatures have not changed all that much until just recently. Over the last 15, maybe 20 years or so, they've come up above their long-term average. But for a long time, there was relatively little movement in the mean temperature for the state. There's the year just ended is that little thing right there, which is about a little more than a half a degree Fahrenheit above the long-term mean. Or actually, what's plotted here is the 1949 to 2005 is the horizontal line. That's the reference period for this graph. And we have a 11-year running mean just to smooth it out a little bit, so you can see the trends a little bit better. So but we can divide this into the daytime maximum and the nighttime minimum temperatures for the water year, and those look rather different actually. The maximum temperatures, daytime maximum, started out on the cool side for about 30 or 35 years or so, but since the 30s have hardly warmed appreciably over that time. A little bit of warming here. We had a couple of cool years just recently, went up again, and then last year it was a little bit on just slightly on the cooler side for the daytime. When we look at nighttime, it's a whole different story. Nighttime temperatures started out the century cool. Over the past 30 or 35 years they've come up, and since about 1990 they've come up really substantially at night. And frankly, we don't really know the reason for this. It's not really predicted very strongly by the climate models, but this is what nature seems to be doing. So we're trying to figure out why night times would go up more than daytime. And if you just flip back and forth here a couple times, you can really see it's decidedly different between daytime and nighttime. So when you see the warming in the longer term climate records, at least recently, most of that seems to be happening at night when everybody's asleep. So looking at precipitation for the state of Nevada, again using the same set of pixels, we just ended, this is the water year precipitation, so it's the October through September reading from 1895-96 up through, it's actually, this is probably mislabeled, it's 2012-2013 is the last figure here. And the last 2 years have been very close to each other, almost identical. And there's that wet year that we've been talking about 2 years ago, and then some dry periods, and that winter, by the way, was about 7th or 8th. And and then if you look at the orange line here, that's a kind of a smooth line, and it has shown not much change, I'd say, overall. In fact, the trend since 1949, shown at the bottom here, is 11%, plus or minus 31% when you account for the uncertainty. So, in essence, no trend in precipitation over the state of Nevada over the past 50, 60 years or so. It really maxed out in the early 80s, which you can well see from these 3 years right here. It's kind of been somewhat downward since, but there's been punctuated by 4 to 6 pretty wet years. Looking at a similar thing for the state of California, so now we're on the western side of the Great Basin. We've divided the state there. We haven't had the luxury of doing this for Nevada, but we've done it in California as part of a project. And this area D here, which we call the Sierra Nevada, generally above 4,000 feet or so, and I've got similar summaries for that area. Also through the water year. We update this every month. It's out on our website. It's under the California Climate Tracker. and within a day or two of the start of each month, it gets updated. So you can sort of track this yourself. And again, this shows the October through September water year temperature for the Sierra Nevada, and it shows a kind of a history somewhat similar to the Great Basin. One difference you do notice is the last 2 years were more above average than they were over the Great Basin, kind of in accordance with those figures I was showing of the maps of where it was above and below normal in temperature in the western states. Again, looking at the difference between daytime and nighttime, got the same kind of figure that we showed earlier for the last 120 years or so. See a similar type of thing. There's 1934 again. This is the warmest year in the Sierra Nevada. Kind of no trend here in mean annual water year temperature in daytime temperature. At night, it's really become decidedly warmer, and the recent year was quite a bit above average in temperature, and although not the very warmest, if we can pick it out here, not the very warmest, it was among the top 7 or 8, I would say, warm nighttime years, warm 12-month night times. And looking at precipitation over the Sierra Nevada, somewhat similar to the state of Nevada. Two years very similar to each other, following the very wet and snowy winter of 2010 and 2011, which again was among the top, well, probably 7 or 8 winters in the state. So we got more variation here in the last 30 years or so, maybe, than in the early years. But if you look at the trend overall, there isn't much trend. In fact, since 1949, the trend is -3, plus or minus 42%. So indistinguishable from no change at all, basically. So one of the other things that we're trying to emphasize here is that these overall patterns do matter, but it also matters the way in which the climate unfolds day by day, one day at a time. And there's tools to look at these on WRCC pages and on other pages. So I'll start with a set of graphs that have been put together by the Climate Prediction Center in Washington. Even though the government is shut down, they've been keeping these up because a lot of the weather information considered pretty crucial for certain things. So we move around the Great Basin here and look at Boise. First of all, these graphs show the last 365 days, ending on the date in question, which here I think was October 11th. And there's the annual cycle that you can see here, and these are the mean temperatures. And anytime it's red, it's above the long-term mean for that day, and blue is below. And then this in the middle diagram is a smooth version of this. It's a 30-day smoother to get somewhat longer-term anomalies during the year. So a couple of things you can see. There's the very cold period that started out the year, well below average in January into February, and then a pretty warm period here from July into September. It cooled off just recently. If you move over to Ely and look at the same thing, you see a similar kind of thing, and not quite so much above average in the recent months, but more above than below during this time. And that really cool period that occurred in January. In fact, if you look at the actual temperatures, which are shown in the bottom diagram here, these are in degrees C, got down to about, I would say, 35 below C, which is about minus 30 below C is minus 22 Fahrenheit. 35 is minus 31 Fahrenheit. 35 C is minus 31 Fahrenheit. So on the cool side, definitely quite noticeable to the people living in that area. If we move over to Salt Lake City, again, show a similar kind of pattern. Cool in the winter and spring with a few warm periods. Almost all warm in the summer months up through just recently at Salt Lake City. And moving on down to Las Vegas, they were warm as well. There's a little glitch here in the data. I'm not sure what this is. They weren't quite as cool in the winter outbreak, but had a somewhat warm spring up until I would say about the start of July, when the monsoon started to come in and we got more clouds. Then the temperatures were not as much above or below. They kind of stayed near average. Average is higher in Las Vegas, but you can see how they dropped down quite a bit on the 30-day running mean. And then finally over here to Bishop, these are the temperatures in Bishop, departure from average, and again they show not quite as much above average in the summer months. In the middle spring to early summer, or even into early July, mostly above average, then fluctuating above and below. Since that time, we've been recently in a cool period here in the Bishop area, and you can see how they've added up down here. Turning to the same set of stations, now looking at precipitation, and what we do is we start 366 days ago, 365, and just start adding up the climatology and adding up the what we got in this particular year. And when the sum of the precipitation of this year is below the climatology, it's colored tan. So Boise started out on the even though they had precipitation events sprinkled all through this whole period here, and the green denoted by the green spikes down in the bottom, they still ended up below average over the last 12 months. Moving over to Ely, you can see some long dry periods here. Then they had this wet period toward the end of summer, and then it's been dry just recently. And you can see down at the bottom here a little flurry of precipitation activity in August and September there. Moving over to Salt Lake City, a similar kind of picture. They got a little bit wetter start to the year. Las Vegas on the right-hand side, they only get their precipitation in a few discrete events. There's one event there that caused this to rise, a couple of smaller ones that caused additional increases, a long time with no precipitation, then some in the monsoon period, but still ended up well below average. And finally Bishop, and this is really very impressive actually. You can see they got some rain in December, and then there's a long hiatus until sometime in May. There's another event, then a long gap, and finally some precipitation in July, and another day here in August. So there's just like 3 or 4 days in this whole record, and that's what's responsible for all of the precipitation you see here. The numbers are a little bit lower than what I said earlier. I think this is from a little bit different data source, and there might also have been some values, I'd have to go check this, that were in early October of last year that might not have counted on this diagram, because this diagram gets updated every day. So a few pictures just to remind you of this is flying down to a meeting in San Diego on August 5th. What we're looking at here is there's Crowley Lake, you can see out here, and looking down toward Bishop and the White Mountains, the Hayes Mountains actually, and you can see how the haze, the forest fire smoke, I think this is from the Aspen fire, really accentuates the topography, which maybe you don't need to be reminded of when you're flying in an airliner, but there it is. So this is the east front of the Sierra, and actually kind of photogenic actually when you look at it out the window. And the smoke kind of hanging down in the valley bottoms, not so much up on the ridges. This is down near Sequoia National Park looking east. That might be Telescope Peak out there, which towers over Death Valley. But you can see the smoke kind of hanging in the valleys here. And this is the Kern River coming up here and then making its big bend up to the left, coming out of the southern part of Sequoia and Kings Canyon National Parks. Again, looking at the effect of the smoke on the Great Basin. And on that same flight, flying into San Diego, just a really very beautiful view, actually looking down into Mexico as we're coming in on our final approach into San Diego. The smoke smoke and some haze and marine aerosols hanging down in the valleys. Almost looks like a Salvador Dali painting of some sort. It looks a little bit surreal, but this is actually exactly what it looked like. So, looking at a few stations here where we can look at at the day-by-day progression on the bottom of snowpack, or just snowfall, that is, the sum of the snow for the year. Precipitation in the middle diagram compared with long-term climatology in tan. And then on top is the day-by-day max and min temperature. The green area underneath is the sort of normal max and min for that time of year, and the pinks and the blues are the all-time record high and low for each day of the year. So you can sort of see if these temperatures are setting any records or not, just by kind of looking at them. And you can see the regime here, the kind of typical regimes you see in the weather. A warm period, then it cooled off, then it warmed up again, then it sort of stayed cool, then it stayed warm, cooled off a little bit in this period here, and you can see a lot of green showing through here, which means that most of the minimums were above average in this area. It's more pronounced if you look at Elko, which is looking at a similar kind of picture. And by the way, Reno ended up with about 6 inches of precipitation, so a little bit less than usual. 9 inches of snow compared with an average of about 25. So a relatively snowless winter in Reno. The snow in Elko ended up to be 42 inches, right about average. The precipitation ended up about 7.7 compared with an average of around 10. A lot of this came on the strength of this little precipitation activity period here in late August, early September. One thing you see here on the top diagram is for a good part of the summer, almost every night was above normal in temperature. Sort of like Lake Wobegon climate, where all the children are above normal. Kind of stayed that way through a good part of the year, and it finally did cool off here toward the very end of this sequence. And finally, this is Tonopah, which is handled out of the Elko office, and they don't have snow, but one of the things this really shows, they ended up right about average, 5.25 inches of precipitation, but a lot of that came in, here's one event that's almost 2 inches, and one more event at the beginning that's another inch. If it wasn't for those two events, they would have been well below normal, and this is kind of a feature of some of these desert climates. One other way we can track what's going on in the atmosphere is we use something called the global reanalysis, and we can, from this, something that's updated every 6 hours, and we get the updates about 1 or 2 days late, and this is a data set that covers the whole globe at about 20 different levels, and goes back to 1948. And we've been using this to put up a tool called the North American Freezing Level Tracker, and I happen to pick this area right around the Ruby Mountains here to illustrate it. I don't expect you to memorize this, but I'm trying to show basically what these show are red is above average freezing level, blue is below average. You can do this yourself. You can come up with these diagrams yourself. I just put them all in one place here. So we start with October in the middle here, and I just kind of loop them around so I don't have to shift them around each time I update them. What these show are the progressions from 1948 up through the current year for the months that are listed. So this is a time series of October freezing levels, and you probably have a hard time reading what the numbers are, but basically when the freezing levels are high, the temperature is high. But this is the temperature at elevation, the temperature up where in the higher elevations of the mountains rather than down in the valleys, because a lot of important stuff that happens up there that is not really we're not exposed to when we down in the playas where most people live in the low spots. And these show a few things. One is the main thing that's probably a good takeaway from this is the time histories in each of the months are all rather different from each other. They don't look all that similar. So there's something that's causing each month to have a somewhat different pattern, temporal pattern to its temporal evolution. So we start with October, November, December, then January, February, March. This was for the previous Great Basin Climate Forum. Then the last 6 months are on the top here, April all the way up to September. And about the only thing I might want to point out a little bit is July has an interesting phenomenon. Not a lot going on in freezing level or temperature up until about the year 2000 or so. Then Julys have been generally pretty warm since then. August, a somewhat similar picture, a little bit longer. September and fall have not really been doing a lot, but we've had a lot of warm Septembers just recently. Okay, so since we're interested in the mountains, I happened to be driving in last night and got this nice view of the White Mountains. And if you look, whoops, what happened there? Okay, if you look at the top of White Mountain, right here, and maybe magnify it just a little bit. Let's see if we can move this. You can see right up there is the summit hut, and right on the very top of the summit hut is a real thing of beauty called the weather instruments, and we just got those going yesterday. They've been down. We had a communications problem for about the last year or so. The information is now beamed down to here in Bishop and to the web pages on the Western Regional Climate Center. They're updated about every 10 minutes or so. Hopefully this will run year-round. We have a really high-quality anemometer up there, and this is at 14,225 feet. It's the highest live site anywhere in North America for meteorological data, and we really try to keep this going. So we've got a record from there that extends about 4 or 5 years or so, and what we've done is taken and compared the record at that site. So here's a photo showing, again, from Southwest Airlines, looking west. There's White Mountain Summit right there, and looking out over Bishop, and then the High Sierra back here looking west. And there's a balloon that's launched over central Nevada at Desert Rock near the test site twice a day, and we have those back to long way back in time, and it's on this grid that's shown down here. And we can pick out the daily values from this grid and compare them to the daily values that we've gotten from the top of the mountain right here at about the same level in the sky. And when we do that, we find that they are really highly correlated with each other. You can see a scatter diagram of them here. And if we form an average, we've got a project with the National Park Service to look at this. When we compare those values, we can use the values from this gridded data set to infill days when we had a data problem of some sort. Sensors were out or communications were down or something. And about 95% of the days we can estimate the mean temperature correctly within about 2 or 3 degrees C. We know this because we make an estimate for every day when we do have data, and we can see how good we do. So this enables us to fairly confidently know what's going on up there, and so we just simply took this and projected it back and to the beginning of this record, 1948, from the global network. And this shows what, if we had had a thermometer running at White Mountain, this is our estimate of what it would have showed. And it does show a general warming here beginning in about the middle 70s or so, and the mean temperature there is minus 5.6, so that's maybe what, 21, 22 degrees Fahrenheit, somewhere around there. It is below freezing, but we've had some warm years lately, a lot of them, and last year was at or close to the warmest on record for this 65-year period here. It's a project I'm working on with Matt Fearon at the Western Regional Climate Center. Okay, so because of these warm temperatures and the lack of precipitation, everybody's aware of these fires that took place. Here's a MODIS image from the satellite on the 22nd of August showing the American fire up here and the Rim fire on the day it really took off. Sent a giant plume of smoke up over, you can sort of see Lake Tahoe there. You can't see Reno, it's underneath. There's a couple of plumes here. And the next morning there was a heavy layer of fog sitting down in the valleys, covering almost the entire Great Basin on August 22nd. On the 26th, again, these plumes still kept pointing the same way, sending a lot of smoke up our area, our being Reno. on the 27th, you can see a plume continuing and showing another little feature here, which is wherever the plume is, this is all around middle afternoon or so. It's suppressed the heating that takes place at the surface, and therefore you don't get the cumulus clouds forming, and the clouds are kind of around the edge of the plume, but they're not right in the center of it. So looking out our windows here at the Desert Research Institute in Reno, this is some of the scenes that you saw looking at the plume from the rimfire, which is about 125 miles away as the crow flies, and as the smoke drifts from Reno. And I had to drive over to Sacramento that day and drove through a second plume. This from the American fire, and there's a nice view of the sun trying to peek through the plume from the American fire, which seemed like a big deal at the time, but then it was completely overshadowed by the rim fire. I had a couple of nice sunsets that you could see from our window here at DRI on the 26th, and there's a little bit wider view of the same thing. We also had a very interesting thing happen. This is just before the rimfire blew up. Looking out of our window here at DRI, this is right next to my office, just around the corner from it, and looking out our Safeway windows down here at the Truckee Meadows, you can see this big blob here, which turns out is a kind of like a wall of smoke that came in on a thunderstorm outflow. And this normally smoke just sort of filters in, but this came in a big blast, and that whole area here moved across from here across the Truckee Meadows and across to the left-hand side of the photo, probably within a space of about 15 minutes. And it was like one of those dust storms you see in Phoenix. This is normally what our visibility is like looking out of my office in Reno. We look right down on the city. There's the Grand Sierra Resort and the airport, and we're looking down here toward Heavenly and Bishop down here, and there's South America down there a little bit further. So that's kind of on a typical day. Here's when that smoke came in. This was on the 24th of August, and then again on the 27th. The whole city is just about gone. And here's on the 1st of September. So this is 8 or 9 days of very, very low air quality. Since we have people who specialize in measurements, we set up some aerosol counters on the roof of our building just about 20 feet above where I took this picture, and some inside the building, and it was way beyond the health standards on the outside, but well below them on the inside. And in the room where a filtered room, there were practically no smoke particles at all. So it really shows how well a good air conditioning system can take out some of these particles in the atmosphere. It's better to be indoors actually in a properly ventilated building than to be outdoors from a lung standpoint. And again, here's one more picture from the first. So we had in downtown Reno pretty poor conditions here. The bus driver can barely see. The pedestrian is about to hit there. Because of air quality concerns, we had a whole weekend worth of football games that were canceled in high school footballs because of the smoke in the air. So this had really sizable consequences, because this smoke plume was going over a pretty major city of about 350,000 people. There's another nice image of the rimfire, which is taken from a new satellite that went up. It's called the Suomi Polar Orbiting Satellite, an instrument called VIIRS, which has a very, very sensitive visible light meter or imager that can record visible light at night. And it can see cities very well, but it can also see the outlines of fires. There's the rim fire on the day it started, and you can see the rim of the rim fire is getting bigger and bigger. It only burns on the edges because it's already burned the inside. You can see how it's expanding day by day. There's the active front more on the south side than the north side here on this one particular day. But this shows how the fire expanded. This really gives a good idea what the perimeter of the fire is and where the active flames are occurring each day. This is over about a 16-day period or so. So what are we left with? This is a false color image of from MODIS again at 250 meter resolution. Mono Lake, Crowley Lake. Here we are in Bishop right here, down here. And this big spot on the landscape is the fire scar that's left over from the rim fire, which is about a little bit less than 260,000 acres, the third biggest fire in California's history. So looking at the drought monitor for the United States, the most severe drought, at least on the 8th of October, was found basically in the Great Basin, what's called D4 here, which is the lowest category on the scale, the most exceptional, the driest category. And we have somebody on our staff, Dave Simmerall, who helps put this map together a few times a year. There's a team around the United States that hands off this pretty complicated task every week to put this out. And we have all the counties in Nevada are designated as secretarial drought designations for the USDA right now. All the ones in red are in that status. So how about the drought conditions over in the Colorado River? So this is the Colorado River, and there's the dividing line there at Lee's Ferry between the upper states and the lower states. And everybody's seen these pictures of the bathtub rings. And the question is always, are the bathtub rings going to get wider or narrower this year? So just one little comment before we discuss that. Every 10 years we shift what's called the normal period, which is 30 years long. We shift it ahead by 10 years. And the new normals are actually quite a bit below. We just changed them from last year to this year as the reference period west-wide, and they dropped from about 8,000 acre-feet, or about 8 million acre-feet, down to a little over 7 million acre-feet. They dropped by 11%. So a value last year that was 100%, this year is 89%. Sorry, it's the other way around. A value last year that was 89% of average, because the means have dropped, is now this year called average. So this is just a little thing to be aware of, and you can see why it's diminished here. This is the inflow into Lake Powell, and you can see there's a steady sort of trend over the past century or so of these 30-year means getting generally lower and lower. This is also the case up on the Boise, on the Snake River, so it's not just on the Colorado River. Well, looking at the storage behind Lake Powell, which a few years ago, well, it's been low ever since the start of the drought in around 97, 98. It's been dropping ever since. Came back up a little bit, but it's now down to 45% of capacity as of September 11th, and the reservoir elevation has dropped 70 feet over the last 2 years. It's probably going to drop another 10 or 15 feet over the winter. And you can see why everybody is so interested in what this next winter is going to bring. Is it going to go down some more, or maybe recover a little bit? So it's currently 110 feet below full. Lake Mead, this is the history of Lake Mead elevation, and it's currently sitting at 47%. Powell is 45%. So these are the two biggest reservoirs in the United States, about half full or half empty, depending on which way you want to view stuff. But they've lost about half their water supplies